Greetings Year 10 and welcome to an exciting class about graphing circles. So let's talk about three important things that we need to understand. The first is the simple equation for graphing a circle. They do get trickier. This is the simple one. This one here. X squared plus y squared equals r squared, where r stands for the radius. And the center of this circle is at 0, 0. So for example, if I had this, x squared plus y squared equals 9, that would be a circle with a center at 0, 0 and a radius at, what's the square root of 9? The square root of 9 is 3, so it'll be a circle with a center at 0, 0 and a radius of 3. This is a formula you just need to memorize. Using a table of values will be useless to you. If I gave you this one, x squared plus y squared equals 81. That's a circle with a center at 0, 0 and a radius of the square root of 81, which is 9. If I tried one like this, x squared plus y squared equals 1. That's a circle with a center at 0, 0. The center is always at 0, 0 for an x squared plus y squared graph, and the radius is the square root of 1, which is 1. If I was going to get a little bit trickier, I might ask one like this. X squared plus y squared equals 5. Well, that's a circle with a center at 0, 0, because the center is always at 0, 0, and the radius is the square root of 5, which is a messy decimal. So just leave it as square root 5, leave it in exact form. So that's our first point that we need to understand. When an equation is in the form x squared plus y squared equals the radius squared, it's always a circle. The next thing we need to understand is our next formula. Now, before we do that, let's look at this. X squared plus y squared equals r squared. That's our formula for a circle. If I wanted to get x squared by itself, I would minus y squared to both sides. So I'll do that. And that leaves me with x squared equals r squared minus y squared. Now if I want to get x squared by itself, I need to take the square root of both sides because that's what gets rid of the squared. But remember, when you're taking the square root and you're dealing with squared, you've got the plus case and the minus case. So the squared and the square root cancel. You're left with x equals plus or minus the square root of r squared minus y squared, which is this rule here. If I wanted to do the exact same thing, but this time I want to get y squared by itself. So I'm going to minus x squared to both sides, and if I do that, leaves me with y squared equals r squared minus x squared. Take the square root of both sides, and you get y equals plus or minus the square root of r squared minus x squared, which is this line. Now, what does it actually mean when you get a formula like that? Let me just randomly choose. There's 4 formulas here. There's x equals plus the square root of r squared minus y squared. There's x equals minus the square root of r squared minus y squared. So that takes into account this situation for the plus case and the minus case. There's the plus case, there's the minus case. Let's now look at this situation. I could have y equals plus the square root of r squared minus x squared, or I could have y equals minus the square root of r squared minus x squared. Now what you need to remember is for every single one of these 4 situations, r stands for the radius. But when you actually have formulas that are written like this, and they're in these forms, they're not full circles, because what actually happens is we create half circles. And you'll see why when I draw the graph, hopefully. If I look at, say, this one here and this one here and compare the two graphs, x equals plus the square root of r squared take y squared is, let me draw it, I'll draw it in blue, is a semicircle to the right hand side of the circle, and its radius is still r. If I look at the second one, it's a semicircle on the left hand side, and its radius is still r. If I was to combine this one and this one together, I would end up with the right circle and the left circle being on a graph, and that would give me the full circle. So if I was to try something like these two, y equals the plus case is the top of a semicircle, and y equals the minus case is the bottom of the semicircle. And if I actually wanted to think of that part and that part on the same graph, it would be the whole lot. So the plus and minus case give me the whole circle. The plus and minus case over here give me the full circle. So you see there's 4 different types of semicircles. How do you know which one's which? Well, if you look at this one, it's on the positive side of the x-axis. This one is on the negative side of the x-axis. This one is on the positive side of the y-axis. And this one is on the underside or negative side of the y-axis. So that's how we could remember how they go. So it's a case of trying to remember that when you've got these square root signs, you are dealing with half circles, which are better known as semicircles. So let's actually now do the example, the first example. It says, let's consider x squared plus y squared equals 9. Well, x squared plus y squared equals something is always a circle, and the center is always at 0, 0. So let's state what the radius is. Well, for this question, the radius is equal to whatever the square root of 9 is, and the square root of 9 I know is 3. You don't have to write square root 9, you can go straight to r equals 3. Let's find the values of y when x equals 2. So we're focusing on the formula, and everywhere we see x in the formula, we're putting 2 in its place. So the formula now becomes 2 squared plus y squared equals 9. And if I look at that, that gives me 4 plus y squared equals 9, minus 4 to both sides. That gives me y squared equals 9 take 4 is 5. And take the square root of both sides and you get y equals plus or minus the square root of 5. Because remember, when you take the square root of something that's already squared, you need to remember the plus and the minus case. So there are 2 y values, which makes sense when we draw the graph. Find the values of x when y is equal to 1. Okay, so let's try that. We're going to use our formula again, but everywhere in the formula where I see a y, I replace it with a 1. So I'll do it over here to the right. X squared plus, instead of a y, I'm putting in a 1. 1 squared equals 9. X squared plus 1 equals 9. Let's minus 1 to both sides. 9 take 1 is 8. Now I take the square root of both sides, but remember there is a plus case and a minus case. And some of you that remember surds may remember this goes down further Square root of 8 is square root of 4 times the square root of 2. So x equals plus or minus 2 square root 2, because I know the square root of 4 is just number 2. But if you leave it like that at the moment, that's fine, but ultimately you need to remember your surds. Okay, let's sketch a graph showing the intercepts. Okay, we know this is a circle, so we can draw a circle. What do we know the radius or the center is? We know the center is at 0, 0. We know the radius is 3. And if the radius is 3, that means my intercepts are at 3, minus 3, minus 3, and 3. Because the distance from the center to the outside of the circle is always 3 units. So there's my sketch showing the intercepts. What's the domain? Now remember, the domain, we talked about it the other day, is the permissible x values of this graph. So when you look at this graph, remember, this is the x-axis and this is the y-axis. So when we look at the permissible x values, we're talking about how far does this graph go in the x direction, so left and right. What are the permissible values to the left? Is there a value of x equals minus 5 that actually involves the circle? No. The circle only goes as far to the left as minus 3 and as far to the right as plus 3. So it goes from minus 3 to plus 3. And remember, the domain or permissible x values talks about x. And when we're talking about between minus 3 and plus 3, that's how we write the domain. For the range, we're talking about the y values, the up and down distance that the graph travels. Now, how high does it go? It only goes as high as plus 3, and it goes as low as minus 3. So when you write the range or the permissible y values, it goes as low as minus 3 in the y-axis, as high as plus 3 for the y-axis, and their y values. So the domain and the range look almost the same, but it's important that for the domain you have the letter x and for the range you have the letter y, because the domain talks about what are the permissible x values and the range talks about the y values. Okay, let's continue and have a look at our second example. And it says, find the coordinates where x squared plus y squared equals 9 intersects with y equals 2x. That is a circle. It's a circle with a centre at 0, 0 and a radius of 3, because the square root of 9 is 3. That is a straight line. We want to find where a circle and a line intersect. So we're solving a simultaneous equation. So to solve the simultaneous equation, we'll use the substitution method and we'll go substitute y equals 2x into x squared plus y squared equals 9. So everywhere I see a y, I'll put 2x in its place. So that gives me x squared plus, instead of a y, I put a 2x in its place, and that's got to be squared. Notice the brackets. They make a huge difference because it now becomes x squared plus, what is 2x squared? That means 2x times 2x, which is 4x squared, and that equals 9. 1x squared plus 4x squared gives me 5x squared. Now we're going to divide both sides by 5. And now to get x by itself, we have to take the square root of both sides. But remember, plus case and the minus case. So x equals plus or minus the square root of 9 over 5. But I want to actually push you a little bit now. When I look at this question, I could treat it like this. x equals plus or minus square root 9 over square root 5, because when you have a big square root sign over a fraction, you can take the square root of the top and the square root of the bottom separately. And I know what the square root of 9 is. I know the top, the square root of 9 is just number 3. The bottom, the square root of 5, I do not know, so I just leave as square root 5. Now let's also test your memories. When you're dealing with surds and we have a surd on the bottom of the fraction, we're going to rationalize the denominator. So we're going to times the top and the bottom by square root 5. And when we do that, you get x equals plus or minus 3 square root 5 over 5. There's a rationalized answer. Well, we now know that line meets that circle twice. It meets it once when x is plus 3 square root 5 over 5, and once when it's minus 3 square root 5 over 5. That's okay. So I'm going to tell you right now that that part there, that's a sort of an extension on this topic. As long as you can get it to there, I'm happy temporarily. Ultimately, you need to be able to go all the way through. So we're solving this simultaneously, remember? So we're going to keep going and we'll say sub x equals, now I'm going to choose using this. There's a reason why I'm going to use this, but I've got to use the plus case or the minus case. I've got to do this twice. So I'll use the plus case first. Oops, change to the pen. I'm going to substitute that into x squared plus y squared equals 9. So when you look at that, the x value is square root 9 over 5. Now, what's the square root of 9 over 5 if you square it? Well, the squared and the square root sign cancel each other out, just to leave you with 9 over 5 plus y squared equals 9. Let's minus 9 over 5 to both sides. Now I've got my calculator here and I'm now typing in 9 minus 9 over 5. And when I do that, I get y squared equals, now 9 minus 9 over 5 is 36 over 5 according to my calculator. And remember, when you get a question like that, we need to take the square root of both sides to find out what y equals. There, which means that y is going to equal, let me undo that and do that in blue. Y is going to equal plus or minus the square root of 36 over 5. Let's just pause for a second. If I substitute x equals minus square root 9 over 5, where did I get that? Remember over here I got two answers. I did the plus case here. Now I'm doing the minus case here. So if I substitute that into x squared plus y squared equals 9, I'll get minus square root 9 on 5, all in brackets, squared plus y squared equals 9. Now what happens to that minus when you square it? Minus times a minus gives a plus. The square root and the squared cancel. You're left with 9 over 5 plus y squared equals 9, which is the same as what I had there. So you're going to get the exact same answer of plus or minus the square root of 36 over 5. Now just like I did here, just so you can see it happen, I'll take this further. I could say y equals plus or minus. Now let's do the square root of 36. The square root of 36 is 6. Let's do the bottom part, the square root of 5, which is square root 5. Now I'm going to multiply top and bottom by square root 5 because I want to rationalize the denominator. If you're not sure what I'm doing, I can go through this with you later. But just to give you an idea, rationalizing the denominator was on the HSC exam, which was today, the day I'm recording this. So they happen in HSC exams. So learn them now because they're going to keep on occurring. So we get plus or minus 6 square root 5 over 5. Now, let's actually have a look at what this means. It says sketch the graph as well. If I sketch the graph, I instantly know the first one is a circle because it's x squared plus y squared. And the center is at 0, 0, and the radius is, what's the square root of 9? 3. So if I draw a circle with a radius of 3, that means that's at 3, that's at 3, that's at minus 3, that's at minus 3. That's the circle drawn. What does the line y equals 2x look like? Now, I can draw it quickly, but if you're not sure, this is what I'm thinking of when I draw this. I'm just quickly doing a table of values. If I let x equal 0, 2 times 0 is 0. If I let x equal 1, 2 times 1 is 2, which means the point 0, 0 and the point 1, 2 are on my line. So let's go to 0, 0. Let's go out 1, up 2. That'd be roughly there. Let's join those, and that is my line y equals 2x. This point here is one of the points of intersection. It's in the positive x direction and the positive y direction, so that point there is 3 square root 5 over 5, comma, 6 square root 5 over 5. Where did I get that from? I got that from the positive answer here and the positive answer here, or here. Now, I could have written plus square root 9 over 5, comma, plus square root 36 over 5, but this is a more simplified answer because I've gone through the process of reducing it to a rationalized form. This one is going to be minus 3 square root 5 over 5, comma, minus 6 square root 5 over 5. Now this is a really difficult question. And I intentionally gave you a difficult question here so you could see it as a mess. You're not often going to get questions this difficult, but you need to be able to understand it because down the track, HSC, there will be some questions where you'll have surds and rationalizing and things like that. It's just part of the course and you're expected to ultimately be able to do this. So there's example 2. Now a case of you doing some questions. Have fun.